to copy all of them and you tell me what you would like, or we can do all of them. So the integral from 0 to 2 from f of x dx. Then the integral from 0 to 5 from f of x dx. And then the integral from 5 to 7 from f of x dx. And then the integral from 0 to 9 from f of x dx. Okay. So the integral from 0 to 2 is this area. Let me use a pencil. Do I have a pencil here? I do have a pencil here. Okay. So this is the area between 0 and 2. How do I determine it? Okay, so this is the area of a trapezoid. And the area of a trapezoid is big base plus small base multiplied by the height divided by 2. So the big base is 3. The small base is 1. The height is 2. So 3 plus 1 is 4. 4 times, and 2 goes away. So this is 4. Then I'm asked to find the integral from 0 to 5. But the integral from 0 to 5, from the properties that we just looked at, will be the integral from 0 to 2, which I already have determined in part A. But I have to add this area, which is another trapezoid. Big base, 3, plus small base, 4, multiplied by 3, 4 multiplied by 3, and divided by 2. So I'll simplify, and I get 6. So this is plus the integral from 2 to 5 from f of x dx. So this is the first, which is 4, plus the second one, which is 6. So the area is 10. Okay, now we want to determine the area between 5 and 7, which is this area. But that has to be a negative area, which is easy because it's base times height divided by 2. This is a triangle. So the base is 2, the height is 3, 6 divided by 2 is 3. Finally, we are asked to find the area from 0 to 9. Well, the area from 0 to 9 will be the integral from 0 to 5 from f of x dx, which I already have, is 10, minus 3, which is the integral from 5 to 7, and then minus, and I have to determine the integral from 7 to 9. So the integral from 7 to 9 from f of x dx is also a negative area, and it's another trapezoid, which is this one. Big base, 3, plus small base, 2, so that's 5. 5 multiplied by 2 divided by 2. So that's all I need. So 3 plus 2 is 5. So this is negative 5. So I have 10 minus 8, which is 2. And that is the area determined using trapezoids or triangles. Here is another. Any questions here? Any questions? Okay, moving on. Let's look at the following example. We're asked to find the integral from 0 to 5 from f of x dx. That's the question. And we are given the function as being 3 for x less than 3, and being x for x greater than or equal to 3. Where is my starting point? What do I have to write first? Can anyone help? So it's basically this property, the integral from 0 to 5. This is not 0 and this is not 5, but it's the same idea. The integral from 0 to 5. Since 3 is in the middle, I will have to write the integral from 0 to 3 plus the integral from 3 to 5. So the integral from 0 to 5 from f of x dx is the integral from 0 to 3 plus the integral from 3 to 5. And now I have to establish from what? What goes in each integral? Of course, there must be the x. Without the x, we can continue. But which function will I use? Which function for each? So less than 3 must be from 3, and greater than or equal to 3 must be from x. Way before, I did not wait till this section. We know how to calculate definite integrals. Which function prime is 3? Well, it must be 3x from 0 to 3 plus. Which function prime is x? Well, it's x squared divided by 2 from 3 to 5. Good. I always like integrals with one of the limits 0. So 3 times 3, because when I plug in 0, I get 0. Plus 1/2 outside. When I plug in 5, I get 25. When I plug in 3, I get 9. Always keep the constants outside. They will always simplify your life if you do that. So this is 9 plus 25 minus 9 is 16, divided by 2 is 8. The answer, 17. Any questions? Okay, let's also look at something like this. The integral from 1 through 5 from f of x dx, they are telling us it's 12. Also, the integral from 4 to 5 from f of x dx, it's given to us as being 30, no, it's 3.6. And we're asked to find the integral from 1 to 4 from f of x dx. Any suggestions on this? What do you think?
Would it not just be the opposite of the integral addition rule, where we just subtract these two values from each other?
Because we have from 1 to 5, and we have from 4 to 5. So from 1 to 4 will be the difference. Exactly. That's exactly it. So the integral from 1 to 4, of course, f of x dx, will equal the integral from 1 through 5 from f of x dx minus the integral from 4 to 5 from f of x dx. Why? So here is, if it's not clear, so here will be a potential graph of something like that. So this is 1, this is 4, and this is 5. Here's the function. And we have that the integral from 1 to 5, which is this area, this will be 12. We have the integral from 4 to 5, which is this area, which is 3.6. So then the integral from 1 to 4 will be 12 minus 3.6. So what is that? Is that 8.4? Correct me if I'm wrong.
Yeah.
Okay. Let's use some more properties now on something more interesting. Like, for example, we're asked to show the following. 2 is less than or equal to the integral from -1 to 1 from the square root of 1 plus x squared dx. and it's less than or equal to 2 the square root of 2. And the problem says, use the properties of integrals to verify the inequality. Do not calculate anything, in other words, just verify the inequality. We, at this point, we don't know how to determine this anyway. So we wouldn't be able to do anything other than use the properties. So we're asked to show that this is true. First of all, there is one property, right, that says that if a function has a lower limit and a, not lower limit, but a lower bound and the upper bound, this is the property I'm referring to, then the integral from this dx, the integral from this dx, the integral from this dx are still in the same relationship. Of course, all of them from a to b, definite integrals. So this is the idea, and this is what I'm trying to establish. My starting point has to be the limits of x. These are the lower limit and the upper limit for x. So I know that x is a number between -1 and 1. According to this, we don't care what happens outside. Now, what I need to build in the middle is the function, because I cannot use this property if the function is not in the middle. But this is not the function. The function has the square root and has 1 plus x squared. I always said never square both sides of an inequality, and I'm not going to square. But knowing this, I'm going to ask you, what are the lower bound and the upper bound of 1? I did not square. I did not square this 3 sides of the inequality. No, I did not. But let's just think for a moment. If x is a number between -1 and 1, where will I find x squared? Between what and what? We're just thinking, we're not squaring.
A 0 to 1.
Excellent, of course. Absolutely. Do we all agree with this? Did I build the function in the middle? No, 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 not yet. The function has x squared plus 1, but that is not a problem. I can add 1 to all 3 sides. Okay. Did I build a function in the middle? No, not yet. Now the question is here. I said a long time ago, do not take or do not apply the square root on 2 sides or both sides or 3 sides of an inequality. But this time I'm going to say yes, that is allowed. How come? I changed my mind? No. But these numbers are all positive. So if I have 2 less than 4 less than 9, if I take the square root because they're all positive, the relationship is still true. That's why I'm allowed to. Okay? So I'm going to do this then, because they're all positive. So when I apply the square root at the same time to all 3 sides, they will still stay in this relationship. So now I'm very close. My lower number is 1 because the square root of 1 is 1. My upper number is the square root of 2. So I am ready to apply the relationship that says, a relationship says this. If this happens, then this happens. Because this is one of the properties of the definite integral. The middle has to stay. I cannot do anything to it, but I don't even want to. I'm happy with that. But I know how to determine this integral. Which function prime is 1? Is x, from -1 to 1. I know how to determine this. Which function prime is 1? It's x, from -1 to 1, because the constant goes outside. And now, let me move this out of the way. And now, this. When I plug in the upper limit, I get 1 minus when I plug in the lower limit, but I have to change the sign. Same thing here. When I plug in the upper limit is 1 minus 1, so this will be 2 the square root of 2, and this will be 2. And this is exactly what they wanted us to show. That the integral from -1 to 1 from this function dx is between 2 and 2 the square root of 2, and that's what we showed. And this is an application of the properties of definite integrals. Any questions before we continue?
So going back to that x squared part,
Yes.
so you didn't square it, so what exactly happened there then?
So if I have a number between -1 and 1, and the function is x squared, the function looks like this. So the y values of this function are between 0 and 1.
So
So if x is between -1 and 1, look at the function, and you'll see that x squared must be a number between 0 and 1 as a result of that.
okay. So you just made a statement to help you figure out the problem.
No, I didn't make up a statement. Every time x is between -1 and 1, it is mandatory that x squared will be between 0 and 1, according to the function's graph. That's always going to be the case. If the number is between -1 and 1, x squared, function x squared will be between 0 and 1.
Okay.
That is carved in stone. Is that clear?
Yes.